Okay, so let's talk about the sum or difference of two series. So usually this kind of question, they would expect you to expand, okay, using a Maclaurin expansion from MF26, okay, each one of these series, okay, and then sum it up or take the difference, okay, depending on the question. So usually what we'll do in step number 1 is that we will expand and simplify, all right? Simplify each of the series independently. Okay, so we'll do it one by one, and then after that, step 2, we will take the sum, okay, all the difference, all right, by grouping the like terms, okay, like terms, constants with the constants and the ones with the same powers, okay, with the ones with the same powers. All right, now let's say, for example, okay, so this topic or section here is best learned through example. Okay, so let's take a look at example 1. Say that a question gives us, okay, like this, we are asked to use the standard series, okay, from your MF26, expand them and find the sum of cosine x plus e to the power of, say, minus x, okay, up to and including, say, x squared. All right, so this is actually quite simple, right? So what we'll do is that we'll look at our MF26, which I've actually attached to the whiteboard for easy reference. We have the cosine x over here. So in that case, we just have to copy it from our MF26 up to and including the term x squared. So that means we just need the first two terms, which is 1 minus x squared over 2 factorial, okay? And then we can actually put the plus dot dot dot. We talk about this just to tell whoever is reading this, right, that we still have other terms, but we're not interested in them, okay? So we don't need to specify them. Now, next up, we have e to the power of x. So for that expansion, okay, e to the power minus x, we're going to use this from our MF26, okay? And this time, replacing the x with minus x instead. So in that case, we'll have 1, okay, you can use the bracket for more organization, but in this case, since it's plus, okay, I don't really have to worry so much about, you know, the signs. So we have 1, okay, and then replacing the x, we can change that to minus x. Remember, we're replacing with x with minus x, okay, just in case. Now, after that, we need the x squared over here. So in that case, we'll have plus and then minus x holding square over 2 factorial, okay? Again, since it's up to and including the term x squared, we don't need the rest of the terms, so we put plus dot 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 over here. And then now we can go on to, or rather, now this is done for step number 1. All right, so we can move on to step number 2. Okay, we'll take the sum or the difference accordingly by grouping the like terms. So we have the constant, which makes up to 2. And then after that, we also have a single x term, which is just minus x. And then for the x squared term, it would be minus x squared over 2, all right, which is 2 factorial is just 2, right? And then plus, okay, in this case, this guy happens to be x squared over 2, all right? So in that case, this kinds of cancel out. So what we are left with is just 2 minus x, okay? Plus dot dot dot, right? So I realized that this is probably one of the examples that it happens that this cancels out. I was expecting to have some x squared, so there's a little bit of desync here in my example, so apologies for that, okay? But usually in the exams, when they ask for up to and including x squared terms, you would have another x squared term somewhere around here, okay? I just wasn't expecting that they kind of cancel out so nicely. All right. Okay, but more importantly, I just want to make sure that, you know, using these examples, you know how to take the sum or difference of two series, okay? While you have to expand them accordingly by replacing the x values. Okay, now let's take a look at another example. Okay, example 2. This is actually more interesting, all right? Say that we have this question, ln, okay? And then it goes with 2 plus 4x over, all right, 1 minus 2x to the power of 2. 1 minus 2x to the power of 2. Okay, so how do you use the standard series from an MF26, okay, to get the expression for this guy? All right. Now, as with ln, remember that in secondary schools, you have already learned the laws of logarithms, okay? So you need to apply those over here, simplify it a little bit so that you make it in this form, okay? And we can see that we have a division. So we can use the quotient law and split this up, okay? So we will have ln bracket 2 plus 4x minus, okay, since it's a quotient law, right, it's division, is minus. We've got ln bracket 1 minus 2x squared, okay? We're not nearly there yet because you see that we don't have a 1, okay? We need a 1 plus an x term, right? So over here is 2. So what you can do is that you could factorize out the 2, and that gives you 1 plus 2x, okay? All right, which we could use product law to separate the two. And then after that, over here, we have the power rule, okay? Power rule, which allows us to power the 2 down. So that gives us 2 ln bracket 1 minus 2x, okay? So these are actually kind of, or rather I would say, very popular questions that you can get in exams, okay? Teachers like to test this, and sometimes, you know, for some students who haven't come across questions like that, they may not realize that they have to do some simplifications with the logarithms rules first before applying the MF26 standard series formulas. Okay, so remember this, all right? So now you know how to approach questions like that. Okay, we got to simplify this a little bit further. So we're going to apply the product rule for this guy. So we have ln 2 plus ln bracket 1 plus 2x. Okay, so this is great now. We have the form 1 plus a term in x. Okay, and then after that, we have minus 2 ln bracket 1 minus 2x. So for the first guy, what we'll do is we'll replace the x. Okay, replace the x with 2x. And then for the second guy, or rather the third term, okay, for the second term, all right, let's put it that way, we're going to replace the x with 2x. And then for the third term, okay, we're going to replace it with minus 2x, okay? Now, let's remove the clutter. I don't want too many underlines here, okay? So let's move forward with this, okay? So since we don't need the rest, I'm going to screw up a little bit to get more space, but you can still see the formula over here, okay? Right. Now let's go ahead and expand this. Okay, so step number 1 would be to expand each of these series independently. So that will be bracket, okay, so x minus, 2x minus 2x whole thing square. Okay, we have done this a couple of times, right? So I'm just going to go ahead and simplify this along the way. So we have 4x squared, all right, 4x squared over 2, okay? And then after that, let's just do up to x cubed, okay? Let's say, suppose the question wants us to do up to x cubed. Then after that, we have plus, okay, 2x whole thing cubed, that gives us 8x cubed over 3, okay? Now we're going to close the brackets over here. Before that, plus dot dot dot, and close the bracket here. So we're done for this term over here, all right? Now we're going to move on to the next one. We're going to keep the minus 2 on the outside. And then we're going to expand just the ln 1 minus 2x. This time round, replacing the x with minus 2x. So we'll have minus 2x, right? And then we'll have a minus. Okay, so let's use a square bracket over here. The x squared would be minus 2x whole thing squared over 2. Okay, and then plus minus 2x whole thing cubed over 3. Okay, plus dot dot dot. All right, and we're done. So let's simplify this a little bit. Okay, we can expand this, or rather drop the brackets. So that will be 2x minus 2x squared plus 8 over 3x cubed. Okay, after that, let's keep the minus 2. Okay, and over here we have minus 2x. Okay, so this guy gives us 4x squared. So 4x squared divided by 2 is simply minus 2x squared, all right? And this guy gives us minus 8x cubed. So we'll have minus 8 over 3x cubed, right? Now, we can consolidate all the plus dot 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 at the back. So that would mean that I can still use the equal sign. And then next up, we are going to simplify this more. So we have 2x minus 2x squared plus 8 over 3x cubed. Okay, and then minus minus become plus 4x. Minus minus becomes plus again. All right, minus minus become plus again, and then we have 4x squared, negative negative one positive, 8 to 16 over 3x cubed plus dot dot dot. All right, now we are ready to move on to step 2. Okay, so we'll group the like terms and simplify this. Okay, so there's just one constant, which is ln 2, and then we have plus 2x and the 4x over here and here, so that gives us 6x, and then we got the x squared, which is this guy and this guy, so we have plus 2x squared, and then we have this guy and this guy, so that will be 8 plus 16, 24 divided by 3, so that gives us 8 again. Okay, all right, 24 divided by 3, and then x cubed. Okay, and then not to forget the plus dot dot dot. All right, so there you go. That is the expansion for this guy. All right, so as innocent it may be, okay, after you have used the logarithm laws to simplify this up to this point over here, you realize that this is a difference of two series. All right.